Thank you so much for being here. This has been a really rewarding and busy day for our guest speaker this evening. She has been making her rounds across the county and spoke to almost 1,500 local students today, several of them right here in this room. So, So we would especially like to thank St. Genevieve R2, and in particular Melissa Otto and her staff here at the Performing Arts Center for being such wonderful hosts for us. And I think you're really going to enjoy the information that you'll receive tonight. And I'm so glad to see several students who have dragged their families back to get more, because we were pumping that up today to tell the students, you know, tell your families they've got to come tonight to the Performing Arts Center and learn more about this. So without further ado, I'll introduce our guest speaker this evening. Dr. Angela Speck is from University of Missouri-Columbia. She is a professor of astronomy and astrophysics, and I've been texting people all day saying, how often do we get an astrophysicist in St. Genevieve, right? So here we are. This is our quality crowd who is interested in science, especially the 2017 eclipse. So you're going to get some great information tonight, and be sure to ask questions, because she is a wonderful person, a wonderful resource to have those questions answered. She's on the National Task Force for the 2017 eclipse, among many, many other accolades. So with that, I give you Dr. Angela Speck.
I'm going to stay down here. I don't need to be up on the stage. So I'm going to talk to you tonight about this eclipse that's coming, and we're going to start by looking at why we get eclipses. And although this is a rare event here, it's not a rare event across the whole planet. And so I want to talk about why that happens, and then why this one's a particularly big deal. So first of all, I'm going to start with a calendar. What you can see here is how we see the moon change over the course of a month. And so if we're looking at this, actually tonight is a full moon. But over the course of a month, we go from a new moon to the moon getting larger and larger and larger, and from a crescent to half full to gibbous to full, and then it shrinks again. And this is important because we need to understand how the moon is moving around to understand why we get eclipses when we do. And so I'm just going to kind of go very quickly through why we get to see what we see of the moon just every month. Oh, it died. Can you hear me? Oh, yeah. And here's one I prepared earlier. Okay, and so here you can see the Earth, and the sun would be somewhere over there, the sunlight is coming in, and when the moon is here, it is lit up on one side, but we can't see it because that side's pointing away from us. But as the moon moves around, it's still lit up on one half, but from where we're sitting down here, we can only see a little portion of it, so it looks like a crescent. As it continues to move around, now you can see that you're seeing half of the lit up side. And as it keeps moving around, we see more of it until it's on the other side. And now we can see the whole of this lit up side. And it keeps going and going. And so we have a system that's getting bigger and bigger, and then smaller and smaller. And it takes 29.5 days to go from being a full moon all the way around to a full moon, or a new moon, where we can't see it, all the way back to a new moon. 29.5 days. Now, this begs a question. If the moon is here and the sun is over here, why don't we get an eclipse every month? And the reason why is that, although when we look at this, we tend to think as 2 dimensions, that it's all flat, you actually have to think in 3 dimensions. So I'm going to put that together a little bit. And what you can see here, now I've got the sun somewhere over there, and the sunlight's coming in, and normally the moon is high up relative to the Earth, and so the sunlight is hitting here, but the shadow never hits the Earth. And likewise for the full moon, during full moon the sunlight hits the moon and then bounces back to us, and it's not in the shadow of the Earth. But every so often they actually line up, and it's only when they line up that we're going to get the shadow of the moon hitting the Earth, and that's when we get an eclipse. So how often does this actually happen? We need to put together the orbit of the Earth around the sun and the orbit of the moon around the Earth. So I've got the sun in the middle here, I've got the Earth going around, and it goes around and around, Oh no, my laser pointer's going to die. Here we go. It goes around and around, and then here's the Earth and the Moon is going around, but it's at an angle. So in this case, it would be the Moon is below this direction between the Sun and the Earth, and so you still don't get an eclipse. But as it moves around, that slant, that offset is in the same direction. So now, when the Moon gets between us and the Sun, now it's lined up and you get an eclipse. But as the Earth keeps going, it's not lined up anymore. So now the Moon is too high, you don't get a shadow on the Earth. But it keeps going around and it lines up again. So you can see here that what you should get is twice a year. It takes a year for the Earth to go all the way around. And so from here, all the way around to here, you should be getting that lineup every 6 months, more or less, okay? But we don't see an eclipse every 6 months either. And there's a couple of reasons why that happens, and I'm going to get into what that is. Now, just to bring this all together, here I've got the Sun. Oh no, I think my battery died. I might have to get up there and point at things. Here we have the Sun at the bottom, the Earth at the top, and you can see a dark spot in West Africa. And if you're under that dark spot in West Africa, then you cannot see the Sun at all. From there, if you're looking towards where the Sun should be, the Moon is completely blocking it out. Now you'll notice that there's another shadow there that's lighter. If you're in that shadow, the Moon is partly across the Sun, so you can see some of the Sun and some of it is blocked. That's called a partial eclipse. And so what we're getting is that you have to be under that tiny little black spot in order to see a total eclipse. So it's only covering a very small portion of the planet. That shadow, that dark spot, is only about 100 miles across. And so, if you're not under that spot, you're not going to see it. Oh, wonderful. Thank you. I'm going to make it work. There we go. Okay, thank you. Okay, so there's the spot. And you need to be under that. Now, there's something else we need to think about. Everything is moving. So I want you to think about how the Earth is moving in its orbit in this direction. And just to put it in perspective, the Earth is moving at approximately 20 miles every second in that orbit. So it's moving along here like this. At the same time, the Moon is moving like this. It's moving in its orbit, and so this thing is moving that way. At the same time, the Earth is spinning, so the surface is also moving in this direction, okay? So that spot is only there for a few moments as the whole system moves. And so it draws out a path that looks like a ribbon. And what happens is, can't press it hard enough. Nope, not working. Okay. Thank you, but I don't think my fingers aren't strong enough to make that work. So what's happening is that black spot is going to draw out. Oh, excellent. Oh, no. Back. Thank you. But my laser pointer's not working. Okay. So, is it? Oh, there we go. It's just faint. Okay, so what's going to happen is this spot's going to move across here. So in order to see that particular eclipse, you'd have to be in Africa, but you could be anywhere on a path that's from where it is now and across here as that shadow moves. And so what you get is you have to be on a fairly small area of Earth. And so even though we have a total solar eclipse about once a year, although it lines up twice a year, and I'll come back to this, we only get a total solar eclipse about once a year. But you have to be on that right bit of the planet where the shadow is. And so, in any given location, it's fairly rare. So I'm going to show you this animation, and this is for the eclipse that we're going to get. So what this is going to show you is the shadow's going to move. So we've got the Moon, we're basically in the position of the Sun, kind of. And, oh, okay. I'm having some issues with my laser pointer. Give me a second. Go back. Go. Okay, I'm not going to show this. I'll show you another one later. The animation seems to be a problem. We'll come back to that idea in a second. But what you're going to see is that you've got here is, there's just a tiny little bit of the sun missing up here. So as the moon is moving in front of the sun, and this is one from about 5 or 6 years ago, this is real images, the sun starts to disappear as the moon moves in front of it. So it takes about 90 minutes from just having the moon just touching the edge of the sun to being completely in front of it. And when you completely block out the sun, suddenly you see this white fuzzy stuff. It's always there. It's called the corona. It's like an extended atmosphere around the sun. And what happens is that it's very faint. It's about as bright as the full moon, which is only about a millionth as bright as the main part of the sun. And so you've got this thing that's really, really faint next to a really bright thing. So the sun is just so bright that you don't notice that faint thing around it. It's always there, but you don't see it until you block out the main part of the sun. So you're watching this, and you're going to need to wear something to protect your eyes. It's dangerous to look at the sun, even when it's got this much covered up. But as soon as it's completely blocked, it's safe to look at. When the moon is directly between us and the sun, it's only that brightness that you get is only as bright as the full moon. It's not going to hurt your eyes. And I'll show you in detail what you're going to see. But then, you know, the moon keeps moving, so eventually as it moves off, we start to see more of the sun again. The moon's moving off in this direction, and eventually we get the whole of the sun back. It takes about 3 hours from here to here. It takes about 90 minutes for it to get in the way. Here in St. Genevieve, you will get 2 minutes and 40 seconds of darkness. And then it'll start to get lighter again. Now, what you actually get to see in that phase where it's completely covered looks like this. So this is the corona. This is that very, very faint part. It's always there. And you see how it kind of looks a little bit like it's coming out in different directions? It's actually following the magnetic field of the sun. So that gas that's there is really hot. It's about 2 million Fahrenheit. It's so hot that it actually means that the gas is electrically charged, and so it will follow what the magnetic field does. And it's kind of like if you've got a bar magnet and you drop iron filings on it and you can see the shape of the magnetic field, it's kind of doing that. So we can actually do science experiments by watching how this stuff is swirling, and it will swirl as you're watching it, and you'll be able to see that. But that actually allows us to understand about the magnetic field of the sun. And that's really important because sometimes it throws things at us. Now, it does nice things like gives us the northern lights, the aurora, but it also sometimes throws enough stuff at us that it can cause problems with electrical systems and actually shut down electrical grids. So we really want to understand that. So during an eclipse is the only time that we can study the corona because it is so faint that it just gets washed out completely by the main part of the sun. So this is the only time we can do it. Now the other thing that you want to notice are these pink blobs up here, okay? That pink is real. So when you think about the normal main part of the sun, and you know that the light splits up into all different colors, right? It's a rainbow. And it's basically behaving, it's not iron, it's a big ball of gas, but it behaves kind of like, if you've got a metal bar and you start heating it up, if you heat it up to being yellow, you're going to get the same sort of rainbow off it if you pass the light through a spectrum. But when you get to the surface, the density goes down so much that the gas starts behaving more like the gas in a fluorescent light tube or in a neon light. So you think about when you've got a neon light and you put the electric power on and that neon light turns red, right? And what's happening in there has to do with the fact that you've got a gas, a low density, very thin gas inside that electric tube, and you're putting energy into it. So what's happening here is you've got a low density gas and you've got energy going into it, and it behaves the same way, but it's not neon, it's hydrogen. And so that pink that you get is actually the distinct color that you get from hydrogen. And so you can see all of these little sticky outlets here, okay? So that's a real thing that you'll actually be able to see during the eclipse. Now, I want to talk a little bit. I said that you're going to need some protection, and I'll talk more about these as we go on. But these are our Mizzou glasses. We're selling these from our bookstore. So these are, if those of you who went to Mizzou, it has Mizzou logos and tiger stripes and things. The filters in here are so thick that you cannot see anything except the sun. It basically cuts out 99.9999% of the light. So if you try to look at a bright light, like the lights up here, there's still not enough light, nothing gets through. But if you look at the sun, you can see the sun and it's completely safe because so little of the light is getting through. It's 1 photon in a million that gets through. And so it's completely safe. So you need these to watch while it's partial. That is, as the moon's moving in the way and the sun's becoming crescent-like. But these are so thick that when you get to the full phase, you can't see anything, so you have to take them off. So, when it comes time to take them off, you want to know what you're looking for. And this is what you're looking for. So if you see this, you'll see there's kind of some little bobbly bits here, right? You see these kind of beady looking things? They're actually called Bailey's beads. And they happen because the moon is not a perfect sphere. It's not smooth. It has craters, it has mountains, it has valleys. And so as it's moving into place, what you're actually seeing here is where you have valleys and peaks, and you've got an imperfect surface. And so as those start to form, that means you're really, really close to being completely covering the sun, and you can start to take your glasses off. And then it's completely safe for 2 minutes and 40 seconds. And you start to see these pink things. So this is that same pink I was talking about before. So as you see that through your glasses, you go, okay, I'm safe now, I can take them off, and I'm going to watch this and just take it in. And then at the other end, as the moon starts to move off, now your eyes have adjusted. Remember, you've gone from the middle of the day, it's bright, it's sunny, hopefully, and now the moon's got in the way and it's as dark as a full moonlight night. Your eyes start to adjust to that. So as the moon starts to move away, the first thing that happens is you have one of those valleys that will be there near the edge, and suddenly light will stream out and your eyes aren't adjusted to it. And so it kind of flares, and so it looks like this. And what you get is that you can still see part of the corona, and so it looks like a ring, and it has a gem on it. So we call it the diamond ring effect. And as soon as you see that, that's when you need to put your glasses back on. At that point, the sun is about to get so bright that you will hurt your eyes. And so you want to put the glasses back on. But these are all things that you'll be able to watch during the eclipse over St. Genevieve. Now, I mentioned that you only get a total eclipse once a year, somewhere on the planet, even though the Earth and the Moon and the Sun line up twice a year. And that's because of this effect. Now, how many of you have heard of the supermoon? Okay, so for those of you who haven't heard about it, once a year we have a full moon that's bigger than the rest of them. And it's basically because the moon's orbit is not exactly circular. And if you have something closer to you, it looks bigger, and if you move it away, it looks smaller. And so every time the moon goes around, it's got a point where it's closer to us, and a point where it's further away. Sometimes it's bigger, sometimes it's smaller. About once a year, it's biggest and full moon at the same time. And so when it's biggest over here, and it's full moon, that would be a supermoon. Now the problem is that when the moon is at this end, it's about 10% smaller. So you don't notice it because you don't have them side by side, right? But it's actually 10% smaller when it's at its smallest size. And that's not big enough to block out the sun. And so you have a problem that the sun doesn't actually get blocked out. So I'm going to kind of bring this together. Here we've got the sun in the middle. I think I killed it. The sun's in the middle, and you've got the Earth on one side, and then the moon going around the Earth. And the Earth's orbit is also not circular. We're actually closest to the sun in January, and furthest from the sun in July. But the difference is not as big. The difference between when the Earth is at its closest point, which we call perihelion, it just means close to the sun. Astronomers like to use big words to make it sound like it's really hard. It's not. And at the other end, at aphelion, furthest from the sun, it's a little bit, so we're a bit further away, so the sun will appear a little bit smaller, but the difference is only about 3%. So if we're at our furthest point, and the moon is at its furthest point, the moon is 10% smaller, but the sun's only 3% smaller. So the sun isn't as small as the moon, so the moon isn't big enough. So depending on exactly where we are in our orbit, and where the moon is in its orbit, when they line up, on average, only one of them per year actually causes the sun to be completely blocked out, and the other one, it's not quite big enough. And so what we get is something that looks like this. And we call this an annular eclipse, because you can see the edge of the sun. But what don't you see? You do not see the corona. When you have an eclipse like this, it's not total. And even with most of the sun blocked out, because the moon's in the middle, you don't see the corona because the sun is so bright that there's enough light that it still drowns out that pale corona. So I saw one of these in 2012. Here it would have been a good partial eclipse. We drove down to the southwest, to New Mexico, so that we could watch the whole thing. And so there was one of these. And you have to wear the special glasses the entire time. It's never safe to look at it without the special glasses. And you never get to see it go dark, and you don't see stars in the day. When you have a total eclipse, you can see stars in the middle of the day, and it's going to full moon darkness. So even though these happen about as often as the total solar eclipses, they're not as special. You can't do the same science, you don't see the same things. And so that's one of the reasons that we had one of these in 2012, but it wasn't nearly as big a deal as this one is going to be, that's the total eclipse next year, which is 1 year and 3 days, just in case you're counting. So another thing that I want to talk about is how long you get. I said that you guys get 2 minutes and 40 seconds of darkness. An eclipse can last from anywhere from 1 minute of darkness to about 6 or 7 minutes. And it depends on how fast everything's moving, right? And so, what we've got here is, this is the Earth going around the sun, but what it's showing applies to anything that orbits anything else. So whether that's the moon going around the Earth, or a comet going around the sun, or anything. Excellent. Let's back up and find my slides. Keep going.
Yeah.
Should be this one. Yay! Okay. So what's happening here, let's see what happens if I press on this one. Ooh, that's much better. Okay. So what's happening here is, as the Earth is here, it's actually going fast enough that it starts to pull away from the sun. It's fast enough that it's beating gravity, and it's pulling away and it's pulling away. But gravity's slowing it down. You think about, you throw a ball up in the air, and it slows down the whole time until it eventually stops, and then it falls back down. That's kind of what's happening to the Earth. It's pulling up away and pulling away, but the sun is pulling it back with gravity. And so it gets to here and it can't keep getting away, and starts to be pulled back in. But because it's being pulled back in, it's speeding up, just like the ball coming back down. And so as it speeds up, it gets fast enough to pull away again. And it pulls away and it pulls away, but it's not fast enough, and it comes back. So anything that orbits anything else orbits so that it's always going to be fastest when it's closest to the thing it's orbiting, and slowest when it's furthest. So when we are closest to the sun in January, we're moving just a little bit faster than when we're furthest in July. Likewise with the moon. When you have a supermoon, the moon is moving just a little bit faster than when it's at its smallest size. So depending on where we are in our orbit, and where the moon is in its orbit, we get different lengths of time. You also have to account for the fact that if you're on the Earth, it has to do with how fast you're spinning on the Earth, right? So if you're at the North Pole, and it takes 24 hours to go around, it means you do this in 24 hours, but you don't go anywhere, you just stay on the same spot. But if you're on the equator, you're moving in 24 hours through 40,000 kilometers. So at the latitude that we are in Missouri, it means that because of the speed we're going round, we're actually going round at about 1,000 kilometers per hour, just because of a day's spin. And so that also affects how long you get to see things. So you have to put all of those together, and then you're able to figure out how long it's going to last. And so here you get quite a long eclipse. Now, I wanted to show you this one because I said there's going to be an eclipse somewhere on the planet every year. And this actually shows you both the total eclipses and the annular eclipses. The blue ones are total, and the red ones are annular. So only the blue ones are the ones where you get to see a total eclipse. And this is all the eclipses from 2001 to 2020. And what you should notice is that the places covered in blue are a very small fraction of the planet. There are lots of places you can be and never see one. in those 20 years. And so this is why, even though the one that we care about is, I killed that already, the one that we care about is this one here. This one here is the one that we're going to get to see next year. You can see that there's none others in the 20 years, the first 20 years of this millennium, that you can see an eclipse on the US or anywhere in North America. And so it's kind of showing you how rare these things are. The one that happened earlier this year, said there's one per year, was actually in Indonesia. So you needed to be on this blue line here. So you see it's mostly ocean, and then it goes over Indonesia. Now, a lot of people saw it because Indonesia is actually quite heavily populated. But not many people from outside of Indonesia got to see it because it's hard to get to. If you look at some of the others, so my mom wants to see an eclipse, has wanted to see one all her life, hasn't seen one yet. And she keeps looking at these places where they happen. And a few years ago, she was looking at this one. She's like, I could travel to that. And I'm like, you know what, Mom? There isn't a single place on that path that I'd be happy with you traveling on your own. And so one of the reasons that the eclipse that comes here next year is that this is where it goes. Okay, so it's over ocean some of the time, but it's over a country that is relatively safe. And so that makes it very appealing as a place, not just for Americans, but for people from outside the US too. I have another view of this that covers a slightly different time period, and this also corrects for projection effects. So this is showing you, it's from 2010 to 2060. So only a few of these have happened, and the one we care about is this one. But you'll notice over this period, we now have this one, and this one, and this one, and this one, all coming over the US. And so in that 50-year period, we have a lot more than we have had in the past.
I understand what accounts for the difference in the width of the band poles. What accounts for the difference?
So the question is about the difference in the width of the path. So remember I said that the size of the moon is changing all the time? So depending on where we are in our orbit and where the moon is in its orbit, the shadow can be very, you're basically moving the distance between the moon and the sun and the earth very slightly. It will actually change the width. So it varies from about 60 to about 100 miles across, depending on exactly where you are in orbit.
Can you explain a hybrid?
I certainly can. So here's something. Think about this. You're just at that point where the moon is not quite big enough, only just not quite big enough. And in the course of that orbit, it actually gets big enough to block out the sun. You go from having something that's annular, where you can see the edge of the sun, to being total, where you get to see the corona. So we have some eclipses where it actually transitions from an annular eclipse to a total eclipse during it. That's what a hybrid is. Okay? And so this one is showing only totals and hybrids, because a hybrid has total phases, but it's not showing you any of the just annular. Okay? And so we've got all of these eclipses coming, but you still see that the majority of them happen over water, which makes sense because most of the planet is water. But it means that a lot of places it's hard to get to. It's expensive because you have to do a cruise. It could be a really long way. I said that the one this year in March was in Indonesia. The one last year was in the Arctic Ocean. It was between Norway and the North Pole, and the places that you could actually stand on ground were the Faroe Islands and Svalbard. And there are some very amusing YouTube videos of astronomers being chased by polar bears. I recommend looking them up. But people go there because it's the only time we can do some of the research, but they're in inaccessible places. And that's one of the things that makes this eclipse that comes next year such a big deal. So I wanted to show you this one. This shows you all of the total solar eclipses that have happened in the US since the US has been a country. So since 1776. And so I'm going to point out for you, the last time there was a total solar eclipse on the continental US was this one here. And I have friends who saw it, but you had to be up in Washington, Montana, North Dakota. The last time there was one that crossed Missouri was this one in 1869. Not one person in this room has seen the total solar eclipse in Missouri. But if you notice where the path goes, it's going over the northeastern part of the state. It doesn't touch St. Louis, and it doesn't touch St. Genevieve. There hasn't been a total solar eclipse over St. Genevieve or St. Louis or Columbia since the US has been a country. In fact, the last time there was one, you want to answer it, don't you? Go on then.
1442.
Yay, they pay attention. So yeah, 1442 is the last time this area experienced a total solar eclipse. That's kind of cool. It's such a long time ago. I mean, there will be people, I have friends who remember this, especially friends from the New York area, but this 1970 eclipse, and this one here in 1979. But you can see that there are parts of the country, like in the Rockies, where they haven't seen one in that time. And here, where you haven't seen an eclipse since the US has been a country. So this is actually showing you where you have to be to see a total solar eclipse in a year and 3 days. The contours are actually showing you, so if you're on that path that's yellow and orange, which you guys are, you get to see the whole thing. But everywhere else gets to see a partial. And we'll look at this again. And so you can see that even if you're up in Chicago, 90% of the sun is going to disappear. Now, it's never going to go dark like it will here. It'll get kind of twilighty, but it's not going to go dark. You're never going to get to see stars. You're never going to get to see the corona. Whereas if you're on that little yellow red band, that's what you get to see. Yeah.
What accounts for this one seems straightest of the least curve of the eclipses?
So it's actually mostly a projection effect. So if you think about if I'm projecting it onto a globe, so this, if I actually was to put this down, it's actually kind of curved in the projection of it. So, and it's because of the shape of the Earth and the shape of the Moon's orbit, so they're all curving. This one actually does curve, but you don't notice it on this scale. So this is just giving you an idea of how much of the country gets to see it. So Sandra mentioned that I'm co-chairing a task force that's aimed at planning for the entire country. And that's because the entire country gets to see at least 60%. Up in, where's my pointy thing? If we look up here in Maine, it's at 60%. If we look down here in California, it's 70%. That's how much of the sun disappears at maximum. And so you really get to see a lot. And I want to bring this together with kind of thinking about some of the things that we've seen. So I've got this animation up here, and that dark spot is where you have to be to see a total, but that other shadow is where you have to be to see a partial. And we'll see it go around again, but you kind of connect to where that spot goes is where my ribbon is across the map. But if you look at the big shadow, you'll see it covers the entire US, the entire Canada, Central America, Greenland, the Caribbean, and northern South America. A huge area gets to see this. And it's actually a lot of land, which is unusual. Now, the next thing that is kind of cool is, so this is showing you, as it moves along, you're going to see it in different places. So when it goes full the first time here in Casper, and then later in Grand Island, and then it's Columbia, Nashville, and then Columbia, South Carolina. And so when you're watching from here, you could be watching on NASA TV something that's going on in Wyoming and actually get to see that it's already gone full and it's not full here yet, and so on. But you can also see how, like here in Chicago, most of it disappears, but it never quite disappears completely. And the same for Dallas. And so there's a lot that will be able to be seen. Now there's one more thing that I want to talk about for St. Genevieve, because something that is important for this particular location. The shadow of the moon is a circle, which is not really surprising, but if you're close to the center, you're going to be under that shadow for longer, so you want to be as close to the center line as possible. If you're close to the edges, it takes seconds for that shadow to disappear, and the closer to the center you get, the longer you spend under the shadow. St. Genevieve is really on the center line, and so you're going to get a whole lot of people that want to come here from elsewhere because they want to come to the center line. People from St. Louis who might actually be on the path in southern St. Louis, but they only get it for a few seconds, and they want to be seeing it for longer, and they're going to be coming down here. I'll get to that. I will get to that, I promise. So this is another animation. Let's see if I can make this work.
Yeah, published.
So this is kind of showing you the same thing that one of those early animations did. You can kind of see how the spot's not appeared yet, but you're getting a partial here, but you've got nothing missing yet over here. And as the moon is moving into place, we now have the shadow of the moon, and it's coming into place, and you can see it's a really strong partial here in Oregon, but out by us, you're hardly seeing anything yet. But as the moon is moving in, now we're going to see it's going to go full, and we're starting to lose the sun over here. So you can kind of see the overall effect for the whole country of you have to be under this line that the spot is drawing out in order to see a full eclipse, but you can see how much is disappearing. And this actually has the times on it. I'm not sure that you can see that. So it actually starts here at about 11:45 in the morning. That's when the moon first touches, it's taking a bite out of the sun. It takes about 90 minutes. At about 1:15, it will go dark for 2.5 minutes. And then it'll take another 90 minutes for it to come off. And I'll come back to that timing in a little while. So the other thing that you may or may not have noticed when I was pointing out things on that 2020 to 2060 map is that while there hasn't been an eclipse here since 1442, there's this eclipse, no, wrong one. There's this eclipse that goes across here that you get in a year and 3 days, and then there's this one that happens 7 years later. You get to be on both. Now, the center line, you're on the center line for this one, but you're not on the center line for this one. It only just gets you, so it won't be as you won't be as big a destination as you will be for the one next year. In fact, where it meets here, that's Carbondale. Carbondale gets to be on the center line for both. But that means that not only do you have this eclipse that's coming in a year and 3 days, you'll get another one, and people are going to want to come back and see that one too. I will, because the second one doesn't go over my house. So I live somewhere around just north of the center line over here, but the second one is nowhere near my house, so I'm going to have to come down here. Now, I want to talk a little bit about just how many people are going to come to this eclipse. And this is kind of tricky because there hasn't been an eclipse on the continental US since 1979. And that one didn't cross the country like this one does. That one was way up in the northwest. The last time there was one that did that crossed all the way from the Pacific to the Atlantic, was 1918. It's kind of hard to use that as a measure of how many people are going to travel. And so I'm going to show this animation in a second. But what we've done is we've used census numbers to try and understand how many people there are and how many people might travel. And you want to think about this as, how many people come to town for things like the Jour de Fête, and how many people come to town for other things that are going on, or how many people go to St. Louis if Paul McCartney's playing in a stadium there. That's a once-in-a-lifetime thing. How many people flood into town because the Cardinals win something, or think about what happened at the other end of the state when the Royals won. How many people are going to come? So let's start with the people that live on the path. People who don't have to go anywhere is 12 million people. That's for the whole country, okay? But remember that you might be on the path, but you might be at the edge, and so you probably want to move towards the middle of the path so you get to see more. So that doesn't mean that there won't be people traveling from within the path. Now, go back. I need to make the animation go. Come back. Now, at 100 miles from the path, so people who only have to drive 100 miles, it's nearly 50 million. 200 miles, 88 million. 300 miles, 130 million. 400 miles, 175 million, and so on. And the point is, so let's take one of those. There's 12 million people who live on the path, but there's basically 8 times as many people as that live within 200 miles of the path. Now, not all of those are going to be able to travel, but that's how many people there are that can get in the car that day. I said it's going to be peaking at 1:12 p.m. If you're 200 miles away, it's only a few hours drive. You can get in the car that day and be here in a few hours. Even if you're out in California or Maine, you're only 900 miles away. I've done 900 miles in a day, and it's not much fun, but it's doable. And so there is basically no one in the country, except for possibly northern Maine, that is more than a long day's drive from somewhere on the path. So when we're thinking about how many people are going to come to this town, how many people are going to travel to this, And then think about, this really is a once-in-a-lifetime opportunity for a lot of people. They're not going to get to see this again. None of them have seen one so far. Then think about the fact that there's always people that travel to these. There are people who see these every year. They spend money on traveling to these. They're all looking for where they want to go. Then think about, okay, we've got people coming from the East Coast. Well, they could drive down to South Carolina, but it's pretty easy to get in a plane and fly to St. Louis. And if you look at the places on the path, St. Louis looks real attractive for people who want to fly in. They get there, it's not far to get close to the center of the path. So it's starting to get a bit scary. I'm predicting that your minimum is that you will double the population of town for that day. Now, there are some caveats to that which relate to weather, which I'll get back to. But I would say that it's not unreasonable to assume that you will be somewhere between doubling and quadrupling the population of town as people come down to see this. And so you need to be ready. And it's not necessarily a straightforward issue. So this is the path for Missouri. And I wanted to kind of give you an idea of this. So let's talk about St. Louis. Now, the airport is not on the path. UMSL, WashU, not on the path. In fact, that northern edge of the path is right where I-64 is. Actually, one corner of Forest Park will see the eclipse. And not the zoo, and not the science center. And that's where the northern edge is. For where you are, the southern edge down here is south of Cape Girardeau, but north of Sikeston. So this is where it is, okay? But if you're up here in St. Louis, you're only getting a minute. And if you come down to where you are, now you're going to get 2.5 minutes. So you're going to have a whole bunch of people who will choose to come here because it's accessible, and that to Missouri because it's accessible, and then looking for the best spot to come and watch this. So for the whole of Missouri, see the center line is close to St. Joe. Actually, the airport at St. Joe, the old air base, is where you get to see the longest time. That's the center. And then as you move down here, it goes over Marshall, Boonville. It's just south of Columbia, and then comes out and it goes right over St. Genevieve. And so we're going to have a whole bunch of people that are from states to the north, states to the south. We're going to be the closest places for people to go. Think about this. These kids here, they're going to be back in school, and that's a good thing, because the school districts are all gearing up for this, and they're going to have a great time and learn a lot about it. Minnesota doesn't go back to school until after Labor Day. So you've got a whole bunch of kids that are ready to travel. Where are they going to go? We're definitely the closest spot. So we're going to have people coming from all over. There's a question in the back? Now that's a good question. So I'm going to talk about how long this has actually lasted. So no, that doesn't happen. What astronomers do is they're trying to pick the best spot for the science that they want to do and the images they want to take. So you will probably have some people looking a few days out at the weather maps and may want to come here to do observations. And that will lead to some other issues. But actually, so I said it takes about 90 minutes, right? It takes about 90 minutes from the sun, from the shadow hitting Oregon to coming off of South Carolina. So it goes 3,000 miles in 90 minutes. It's going at 2,000 miles an hour. You need a pretty damn fast plane to move that fast. So no, you can't, it's moving too fast to actually chase it. So I wanted to share a couple of things, and this is partly because I'm sure there are some Missouri alumni in here, and partly because these are also things that you guys want to do. So one of the things that's needed are these glasses. Now I think the school district is probably going to buy these for the kids, and they may even buy enough that they'll sell them to grown-ups so that they can make some of the money back, which is actually what at the national level we're recommending is a good way to do distribution. But you're also going to want enough to sell them. And I just want to put this in perspective a little bit. So these are the ones that we've had made for Mizzou. We're selling them through the bookstore. You can buy them online through the bookstore's online site. They have tiger stripes and a Mizzou Tigers logo on them. But you can have these made so that they have your company and your logo on them, and you can either give them away or sell them. Now, I just want to put this in perspective of a couple of things you might want to think about if that's what you're thinking about. First of all, how much you pay depends on bulk, right? But we bought 5,000 of these at 61 cents a piece. We are selling them at $1.49. So it's pretty easy for a school to do something like that, make enough money that they can give one away for every one that they sell and still make some money for the school. And it's not a huge amount for the public to be spending. But if you as a business want to sell them, the annular eclipse that I said I went to, and I went to New Mexico. I have a friend who is the director of the planetarium and the observatory at the University of Colorado in Boulder. And he ran an event for that annular eclipse, except in Boulder, it wasn't annular, it was like it was here, it was a partial. So it wasn't a total eclipse, it was a partial eclipse. He opened up the football stadium. He had thousands, actually about 10,000 people come to the stadium, and they all had to buy these in order to be able to watch, because it's partial, you never get to see a full phase. And there's actually a YouTube video of the hardware store in Boulder, and they kept selling out, and they couldn't keep these things in stock. So if you're thinking about it, I'm pretty sure you can make money on these things. And remember, as long as you can store them, you get another one 7 years later, so you can always sell them again the second time around. So with my national hat on, the whole country sees a partial. I need 300 million of these things. So I want as many little companies buying them as possible so that we actually get lots of them out there. But the other things that you could be thinking about in terms of merchandise, who doesn't go, I mean, who went to a World Series game and then didn't buy the t-shirt of the team that won? Or goes to the Paul McCartney concert and doesn't buy the t-shirt? You're going to have a whole bunch of people want to see the t-shirt, so I brought it with me. And this one isn't actually in the bookstore's online section yet, but this is a baseball cap. It has the US with the line of the eclipse, and then over Missouri it's got the tiger. So these are things that we're selling, but you can imagine having t-shirts for St. Genevieve that are specifically, I saw the eclipse in St. Genevieve type of things, and people are going to want those, especially people coming from outside to say, I was there. So these are all things, and then this is a poster, and I actually talked to the artist today, so let me back up just a little bit. We have this national task force, and we're trying to cover everything. We're trying to cover getting out to places like this and talking to people. We're trying to cover dealing with emergency services. I'll come back to that in a minute. We're trying to deal with education and getting out to the schools, and publicity. There are several national parks and national monuments, so working with those groups. There's an astronomer who works with the national parks and has written books on seeing the stars from national parks, but also does their posters. And their posters are based on the old WPA posters, so if you guys go to national parks, you see these old-fashioned posters that you can get. Most of them were Works Projects posters. The newer national parks have similar ones, even though they're not actually Works Projects. He makes posters for the national parks for the Night Sky program, because most national parks are nice and dark. So he started doing this, and he made posters for the annular eclipse. So we pulled him in, partly so we have access into the national parks, but partly because we want him to make posters. So this is his poster, and in the real version, I actually have them to sell if you're interested. These ones, they're actually in the proper Mizzou colors, and this is Jesse Hall and the columns. But I spoke to him today, and he might be interested in doing a poster for St. Genevieve. And so he's done posters for every state along the path. He's done 2 for the entire country. He's done one for St. Louis that's gorgeous, and he's done one for St. Joe. And one for Hopkinsville. Hopkinsville, Kentucky actually gets the longest duration. You guys get 2 minutes and 40 seconds, they get 2 minutes and 41. So, but they need a poster. So anyway, I just wanted to mention that. But this is stuff that I think, as a local thing, you want to be able to take advantage of this as a marketing opportunity. Now this slide just has text on it, and I just want to talk a little bit. So I talked about, you might have a doubling or more of the population, right? Now there's a few other things that might happen. Did you have a question? I'll get to that in a minute, okay? So let's think about this. Suddenly, so people are going to have to plan ahead, right? I can tell you now that Hopkinsville is already full. That you already have your big hotel already full. Wyoming is already full. The whole of Wyoming. So, and this is more than a year out. So you're going to have people choosing where to come, but you're also going to have people that are thinking, you know, they're only going to hear about it through social media about a year out. No, a year out, a week out. And they're going to decide they want to come. And so, and then we have to worry about weather. If it's clear, then you're still going to have a lot of traffic on the roads just because there are going to be people driving from within 200 miles. They don't need to stay here, they can just come in. So I-55 is going to be a mess. Now you're going to have a whole bunch of people staying in St. Louis because they have more bedrooms. And then they'll come down during the day. So there'll be some coming down 55, some down 44, because you can see it from there, some down I-70. At the other end of the state, it's going to be 70 and 35 and 29. The US route, 61 is going to be a mess. 63, 65, anywhere that you can traverse the path. Now let's consider that it's raining in Perryville, but it's clear here. All the people who've gone to Perryville are coming in. Let's say there's patchy cloud and it looks clear here, but it looks messy in Columbia and it looks messy in St. Clair, which is on I-44. All those people are going to be coming this way. So not only do we have to prepare for doubling to quadrupling your population, but we also have to prepare for what happens when we actually have fairly precise weather, which we may not have until the day of. And that's slightly scary. And so this is the thing where there needs to be some cooperation and some collaboration across different districts and being able to do this, and being ready for, you might have a bunch of people that will come here for the weekend and then it gets cloudy here. You're still going to get a lot of business that weekend, but then they're going to go somewhere else on the day. And we won't know until it's really close to the time. And that's really tricky. But there are going to be so few hotel rooms and so many people looking for food that you're going to have a lot of business regardless of whether this is where they watch. Okay? Because there's just not going to be enough places for everybody. So there's a few things that we have to talk about. My house is on the path. Where do you think I'm going to be? I might be here for the 2024 though. No, I'm actually running the events in Columbia, so I'll be in Columbia. I'm leaving when we're done. I've been here since Monday, so actually since Sunday night. So just looking at this, where to see it? Well, I said it's basically happening at 1:15-ish, right? That's the total phase. So it's from about 11:45 through to about 2:15, 2:30. That's the full thing. But we have a question in the back? Right. That's certainly the sort of thing that at the national level, we're trying to encourage different localities to be thinking about, do you want to do Airbnb? Because even though you have quite a few B&Bs, your microhotel's already full, it's not open anymore. You're going to be full. You're going to be more than full. And you're going to need those rooms. And this is something, so we're having the Olympics right now. 4 years ago, the Olympics was in London. My mom lives in London, and she has a 3-bedroom house and it's just her. And she could have made a fortune if she'd actually done the Airbnb thing. She actually put up stewards because the stewards don't get paid. And London is really expensive. So she actually housed stewards so that they didn't have to go out of pocket to stay in London. But a lot of people made, you know, in London they were being paid 500, 600 pounds a night during the Olympics. You're not going to get that much, but you're going to be able to charge a fair amount if you want to do that, okay? But in terms of being able to see this, basically, if you can see south, you're going to see it. Think about 1:15. Well, it's daylight savings, so it's actually 12:15, but we've added on an hour, right? And so if you think about where the sun is, at noon, it's directly south. That's actually the definition of noon. 12 midday is the sun is directly in the south. But then we have time zones, so it gets messed up. But we're close to the middle of the time zone. So actually, at 1 p.m. in the summer, the sun is pretty much as high as it ever gets, and it's directly south. So as long as you have a view south, and you can see up about 60 degrees, then you're going to see it. If you're out in Oregon, it's earlier in the day, so you have to be able to see east and lower. And likewise, as you move further east, it's dropping down again. But for us here, it's about as high as it ever gets. So for here, it's actually just a little bit west of south. It'll be, think about south as being 180 degrees. It's 185. And it's going to be about 60 degrees up. And so, really, you don't have any tall buildings. So unless you're next to something right in front of you, there's going to be nothing to block the view. So that's another reason why Missouri is particularly attractive, is that for the whole of Missouri, that the timing is such that the sun is really, really hot. And so that makes a big difference. And talking about safety precautions. So we have these glasses, and we want to have as many of these out there as possible, but we need to make sure that people know, okay, you put them on, here's when you can take them off, here's when you put them back on again. But also there's a lot of myths. There's a lot of stories out there, and they're even in textbooks, and they're wrong. And you can understand where they came from, this idea that, you know, suddenly you see the corona. Well, it's always there, but you don't see it because the sun's too bright. But people think that the sun is suddenly giving off dangerous rays. So in the 1979 eclipse, some of the kids up there in the Northwest were hiding under tables in classrooms with blackout curtains, because there were so many myths out there and they were being believed. So part of my job is not only to express the things that you need to do to be safe, but also the things that are myths that say it's not safe. The moon comes between us and the sun. It's actually a little bit less dangerous than usual. It's not suddenly giving off more light. So it's kind of like, if you're not looking in that direction, you behave like any other day. If you need sunscreen on a normal sunny day, then you're going to need sunscreen. That's pretty much all there is to it. But we need to get that word out there. We need to make sure that we have buy-in from various medical communities, because not only do we want optometrists and ophthalmologists to help us with this, we have actually got an endorsement now from the American Society of Ophthalmologists, so they're signing off on the glasses as the best way to do this. But it's August, it's the middle of the day, and you're going to be out there, if you watch the whole thing, for 2 to 3 hours. There are going to be people who fall over because they get too hot. You're going to have people getting heat stroke. You're going to have people getting dehydrated. And so you want to be ready for that sort of thing as well. Just being prepared. I guarantee there's money to be made in just having bottles of cold water around. Or buckets to pee in, possibly. So, you know, when we talk about preparing the citizenry, it's getting you guys excited about it, getting you to know what's going on, and then getting you ready for what's coming. Because for you here, it is going to be disruptive. There's going to be a lot of people come to town. And so having you ready for it. And then on the awareness campaigns. So I'm taking on basically the whole of Missouri, because, you know, that's my job. And so I'm doing things like this and coming out and talking to you guys. But we're also going to be doing some national campaigns. How many of you know who Neil deGrasse Tyson is? How many of you have seen Cosmos? It was a TV show a couple of years ago. So Neil deGrasse Tyson is the director of the planetarium in New York, but he's also, you'll have seen him on TV, he's like the TV astronomer. He's now on board, he's helping us, so we're hoping that we'll get some TV spots at some point. Probably not for another 6 months, actually. So there's a whole bunch of things that need to happen. But, you know, we need to work with emergency services, with all of you lovely people, and make sure that everybody's ready. And I have a couple more things I want to show you before I stop completely. One of them is this animation. Let's see if I can make it work. Come back. No. Go back. There we go. Okay, so this is a closer up animation, and you'll see if you're looking here, this is in the time zone it's in, is in bold. So this is at 10 o'clock in the morning, Pacific Daylight Savings. This really is moving, but it's out over the ocean. And you see how it looks kind of slanted? It's because the moon's kind of at an angle to the curvature of the Earth. And this is where it's going to hit the coast of Oregon. And so you can actually see all the different towns it's going over. So it's the, this is really big, and sometimes on a slow computer it jogs. So now it's over Idaho. There's nothing much there, but it's going to go over Idaho Falls, so there's quite a few people there. Then over Wyoming, it goes over the Tetons, over Casper, and so on. and then into Nebraska. I don't know how many of you have ever been to Alliance, Nebraska, but they have Carhenge. It is Stonehenge built out of cars. That's got to be a pretty cool place to go and watch an eclipse, right? So, but you know, it's mostly small towns. You can see Lincoln's on there, but Omaha's nowhere near. Then it comes into Missouri, and you can see Columbia, Jefferson City, Washington, and here it comes, and then it's hitting where you guys are. Last time I did this, it stopped right there. There we go. Over Illinois, a little bit of Kentucky. It actually goes over Nashville, and they're not preparing, which terrifies me. A little bit of North Carolina, a little bit of of Georgia, out through South Carolina, and out into the Atlantic. And so that's the whole tour, and we've got people that are going to come to the whole path. But one of the reasons that Missouri is such a big deal is that, on average, the weather goes up and down because mountains affect it and things like that. On average, the weather predictions, or based on averages over the years, get worse as you go east. So it looks pretty good in Oregon, and it gets worse. But it's not good on the coast of Oregon. It's going to be foggy just because of the time of day. As you get into eastern Oregon, it gets good. Then you get to Wyoming, and there's some mountains, and it gets bad again, and then it gets good, and so it goes up and down. But, like I said, Wyoming's already full. The population of Wyoming is so small that they really don't have that much accommodation. The same happens in Idaho and eastern Oregon. The population density is so low, there isn't much in the way of infrastructure. There aren't hotels, there aren't places to eat. And as you head into Nebraska, you're still in that same sort of place where there are small towns, but there really isn't anything big on the path until you hit Missouri. And then you hit Missouri and Illinois, and we're in the sweet spot of having infrastructure, of having a big airport, actually 2 big airports, of having lots of places that people can stay, even if it's not quite on the path, but really close. And so I think that and we're a little bit better off than, say, Southern Illinois, because, Carbondale's lovely, but it's really hard to get to. In terms of, here you can just jump on an interstate and you're practically here already. There's lots of little tiny roads you have to go. So I think that Missouri in general, and especially this bit, because you are so close to the longest duration, you're going to get more than your fair share of people because of all of those factors. So I'm just going to put that out there. And the last thing I'm going to show you is just fun, because who doesn't like to end on a joke? And I'm going to let you ask me questions. Thank you. Oh, that's okay. When it comes back to you, you can ask me.
What about using small refracting telescope?
So you can do projection, that's fine. Just be careful not to look through it. You can do that. You can actually do it very easily with a pinhole camera. And one of the things that happens is, so you can do a pinhole where basically you just have a small hole and then you have another screen behind it. And you can actually make that quite big and be able to see it that way. So you don't even need a telescope. You can do it that way. The nice thing about the glasses is it's your eyes that get to see it. And there's something cool about your eyes getting to see it. But because of the way it works, anywhere you've got a small hole, like a pinhole, you get this effect. So where you've got trees, and you've got little gaps between the leaves, you actually will see on the ground all the crescents, because it's behaving like a pinhole camera. So if you watch the trees near you, you'll see that all of the shadows have got crescent phases while the moon is moving in the way.
Will you see corona with a pinhole?
No, but you can look at that directly. So actually what you'll see is, it'll get to being a very thin crescent, and it'll be kind of like it's almost like dark after sunset, but not dark yet, so kind of twilighty. But you'll just see a thin crescent of the sun, and that's all you're going to see. You don't actually see the outside of the moon. There was another question somewhere over here. No? Oh, yep, go on. So actually that's a good point. This is something that's kind of fun. Anything that reacts at night is going to react. So you can think about it. If a bird goes to sleep, then it's going to go to sleep. If it has a night song, it's going to start singing. Same with insects, same with cattle. If your cattle normally go back to the barn, they're going to go back to the barn. But they're only going to do that for the 2.5 minutes, and then it's going to get light again. But it's actually stranger than that. So if you think about, when the sun sets, it takes a little while before it actually gets dark, right? And that effect of how long it takes to get dark actually depends on latitude. I grew up so much further north than here, it takes forever to get dark. The sun goes down and it's light forever. And you go down to like the tropics, the sun goes down and it's dark really quickly. It's going to go dark even faster than that. It's going to be kind of twilighty darkness as it gets to about 99% covered. Then when it's completely covered, it's dark like a full moon night. That's how fast it gets dark. So some of the animals freak out. Plants also react. So if you've got plants like flowers that close up, they will start to close up. So you have all of those effects. And there's some kind of fun thought experiments you can do with that. I want to know what happens to vampires. Because, they get out when the sun goes down. So do they get up and then all get burnt to a crisp because they don't realize it's coming back? And, I'm sure there's something with werewolves as well, because normally you don't get to see the moon during new moon, but there it is. So. You had a question? I'm coming back to that. Did you have a question? Okay. Other questions? There was some more over here. I have a ridiculous collection of Star Wars, but no, that one's not mine. So we actually did that at the annular eclipse, and in fact, because these things are so flat, you can hold them over the camera, the front of the phone, and it works pretty well. The hard part is that you can't see the corona, so if you're trying to do something like that, this is good for when it's in the partial phase, but you have to take it off again, and it's not very, the corona is so faint. If you've ever tried to take a picture of the full moon, it's hard because the light is not very much, and so it tends to end up blurry because it basically has the shutter open too long. And so it's hard to do the corona, but the partial phases you can do no problem. Other questions? Ooh. Okay, so the question was when were we able to start predicting this? So the way you need to think about it is, the math is not that hard. If you think about, you can build a model of this quite easily. You've got some complicated things because you've got the tilt of the Earth, you've got where the moon is in its orbit, and so on. But certainly back through about 1,000 years, and probably back through to the Egyptians. I mean, basically, if you look at anyone who's built structures that are related to astronomy, we've been able to use it as a way of making those predictions. The Mayans certainly knew this stuff. I'm not sure about the Egyptians, but it's somewhere in that sort of, I mean, that's a big range, I know, but, basically with technology, we've always looked at the sky, and this sort of ability, so the hard part is the actual doing this for real. We do it with computers now, so it's easy, but they were building structures like Stonehenge and things like that, and you can make these predictions. So we've been able to do it for a few thousand years. Yes. Okay. Right. So the moon is actually moving away from us, and this has to do with how tides work. What it means is that the moon was once closer to us. So it takes a long time. It moves about 1 millimeter every century. So it's a really long time. So you go back a few million years before there were people, but other beasties were around, and they would have seen eclipses, but they wouldn't have seen the corona, because the moon would have been so big that it would have blocked out not just the main part of the sun, but the corona as well. And as we go forward in time, and it moves further away, eventually it will only give us annular eclipses. So there'll still be eclipses, but now you won't see the corona, because you'll still see the edge of the sun. But it moves so slowly, I'm pretty sure we'll have wiped ourselves out before we get to that point. Just on averages, if you think about how long species last on the Earth and look at extinctions, it's very unlikely that we will be around to see it get to that point. It's of the order of several million years.
Just think about it. That happens again.
So it's actually, yeah. No, it's actually, so you can think about it as being, there is a regular cycle, but it's a very long cycle. So, you know, when you're thinking about it, it takes 29.5 days for the moon to get back to the same position relative to the sun, yeah. And then if you add that together with how long it actually takes to go around the sun, and we think of a year as being how long it takes to go around the sun, that's not quite true. A calendar year is actually 20 minutes less than it takes us to get around the sun. And it gets into all those little fractions, like why we have leap years, so that we actually have whole days in years, and leap seconds, and that's because it's a funny number. It's got like hundreds of digits past the decimal point. And so as you add all of those up, you end up with something where there is a pattern, but its repeating time is of the order of millennia. So you would expect to have a pattern where you get an eclipse and you get an eclipse, and then it's not for a while. And it'll be different on different parts of the planet. But it makes sense once you realize all the irregular numbers that you're trying to put together. Mm-hmm. That's absolutely true. And do you know what we call that? Okay, so yeah, that's true. So the idea of the month comes from, oh, okay. So the question was that since, you know, the idea of the month comes from the moon, but it's only 29.5 days, and so if you add them all up, actually you have 13 moons, full moons, in a calendar year, because we have more days in a month than it takes for the moon to go around. Actually, it only takes the moon to do an orbit 27 1/3 days, but because the Earth also moves, to get back to the same phase, it actually has to do a bit more than one orbit, so that's the 29.5 days. And that feeds into the complication of figuring things out. So yeah, you basically get it's not actually every year, it's about every 2 years. It's actually, I think, 19 months. It adds up so that you'll end up with, in a calendar month, having 2 full moons. So you'll have one at the beginning of the month on the 1st, and then you'll get one on the 30th, right? And we call that a blue moon. So when you get the second full moon in a calendar month, we call it a blue moon. And so it happens. And there was one, I don't think it was last year, it might have been the year before, that the blue moon was also the super moon. And so the press were having a field day. I mean, you know, the moon was really big, and it was the second moon in the calendar month. But our calendar months are kind of arbitrary, whereas what the moon does, it just does it like clockwork. So I like the lunar calendar better. It makes more sense to me. Okay, other questions? Monday. So, and again, in terms of, you're going to have people that will only travel that day, but you're going to have people who are going to be looking for, what can we do that weekend? Let's go and be there that whole weekend. So you're going to have a lot of people coming here, even if they don't come here to watch the eclipse. And then on that Monday, schools are going to be in session, and that's a good thing, because the teachers are all going to be prepped, the kids are going to be ready for it. They actually get a few days of school ahead of this. For us at MU, it's a little difficult, because it's our first day of the semester. So we don't have any prep time with students ahead of that. So I'm working on how we deal with that.
The classes, it seems like it'd be easy to make a mistake, and lots of people to either hook too soon or hook too late. I mean,
okay, so are you?
What kind of damage can it do?
Okay, so the way you want to think about this is, you know, you're outside on a sunny day, and you're avoiding looking at the sun, but it's March and you're heading west at sunset, and the sun's right there, and you can't avoid it. How much damage do you do to your eyes? My point is that if you take your glasses off too soon, your reflex is going to be, oh my God, that's really bright. You know, you're not going to do permanent damage, and the second it takes you to go, so, you know, I mean, really, I think a lot of common sense can be applied to this. You don't want to be looking consistently at the sun without protection. But, you know, everybody's walked out on a sunny day and the sun's right there, and you can go like that, and that's what you're going to end up doing. So, I'm not too worried about it. Okay?
Just going back to Erica's,
Right, so I think there's a few things you want to think about. I mean, if you are people or you know people with land, is that the biggest problem for a campsite is that you need water and toilets. And if you don't have those, you probably want to be an RV site where they bring that crap with them. Or make it clear that this is, so I'm married to a geologist, we do a lot of outdoor stuff. So we actually carry with us a big thing of water, so that if we find ourselves in a place where we just need to camp on public land, so you can camp on BLM land, for instance, as long as you're 10 feet off the road. And the only thing that's really a problem is you're going to have to bury your own poop, and you're going to have to find somewhere to get water, so we always carry water. And so if you've got people like that, that's fine. But that issue of having a water supply and a way to get rid of the manure, that's a problem, I think, for a lot of people. So I'm very, so here in Missouri, the Department of Natural Resources is on this and is working through the state parks, and I'm very happy to try and make those connections for people. But those are the things that I think you really need to think about. Whereas if it's, oh, we've got a space so we can let you put your RV here, that's kind of a self-contained unit. You don't have to worry about all those things. And I think that's a little easier. But, you know, that doesn't mean it's insurmountable. But I can tell you, I know that Sandra's already booked a whole bunch of porta potties because they're already disappearing. It's getting to the point where you're not going to be able to book those things. And so if you want to have a campground, you have to think about that sort of thing.
How about cell phones and...
Don't even try. Okay, so I have season tickets. I have season tickets for the Tigers, right? And I can see the stadium from my house practically. But when I'm sat there, I cannot get onto the internet at all. Either by Wi-Fi, which is available through parts of the stadium, or by, you know, the 4G network, because it's swamped. You're not, and the same happened, I don't know how many of you guys like Stephen Colbert? Okay, so a few years ago, before he became like the late night guy on CBS, he was doing the Colbert Report, and he was on after the Jon Stewart show, and they did the rally against insanity in DC, and you couldn't get any sort of signal anywhere in central DC on that day. It was impossible because there were too many people, and that's what it's going to be like. So yeah, you need, and this is in terms of like this emergency management thing, you need to make sure that people realize it's going to be like you've got such a big festival going on. So for us in Colombia, it's like homecoming meets a big rock festival meets, you know, Mizzou's in a bowl game on our own grounds. You know, that's how big it's going to be, and you might not be able to make calls on cell phones.
So emergency services and even contacting emergency services are in question.
Absolutely. So you need to think about how you're going to deal with that. I mean, personally, I don't have a landline in my house. So, you know, if I was at home and I wouldn't have any way to do anything with it, right? So you certainly want to think about those things. There was a question over here. So the question was about whether you care about streetlights. Now, a lot of the time, because it's in the middle of the day, the streetlights aren't going to come on. Some of them are light sensitive, so they come on when it gets dark. But it's going to be like a full moon night, and so it's not like a dark night, and so it's not so much of a big deal. If you've got like floodlights that come on, then yeah, that's a problem. But the average street light is probably not going to bother you too much. It will affect seeing some of the fainter stars, but with the corona being there and it being darkest next to the sun, you're already not seeing the faintest stars because the corona is quite bright. So I wouldn't worry about it too much.
What about using welder's masks?
Now that's a good question. So here's the thing about welder's masks. You know, they come in different levels and they're numbered. And what you need to use is one that's a number 14 or up from there. And the reason why is that if you think about if you watch someone welding and you see that light that you get from it, it's very blue. So they're very good at cutting out blue light, but they're not very good at cutting out red light. So they're just not designed that way because the torches don't work that way. Whereas these glasses that we have, they cut out the light across the whole spectrum. You've got all the colors cut out evenly. And so unless you go up to a fairly high level, you're getting too much red light. And so if you're looking at the eclipse for an hour, you're going to get too much red light, you're going to do damage. So welding glasses are fine, welding goggles are fine if they're a number 14 or up from there. These are cheaper than welding goggles. The solar eclipse is not going to make electricity shut down. It's not. What the solar eclipse lets us do is study the magnetic field of the sun, and that can sometimes throw things at us that makes electricity shut down. But while we're watching the eclipse, nothing, it's just, you can think of it as being, it's a normal day, but there's a really, really big cloud that's really thick, got in the way, right? It's kind of like that. Something is coming between us and the sun, so it's going to get dark, but it's not going to change anything else on the ground. Does that make sense? Okay. One more question. Go on. So the question was about whether a magnet would be affected. No, not going to do anything at all. So the sun has a magnetic field and it's always there. And the Earth has a magnetic field too, and it's always there. And the only difference is that we can see what the magnetic field is doing just because we blocked out the main part of the sun. Normally we can't see that because the sun's light is so bright it stops us seeing it. So we can see what it's doing, but it's not behaving any differently than usual. Okay, I would like, how many children do we have here? Okay. I have glasses for the kids in the audience. So if you want to come up, you can come and collect some glasses. Thank you, everybody.
While she's doing that, I'll just tell you also that, and Felix, I'm so glad that you're here because that just saved us a whole lot of conversations, didn't it? Of course, all these things, we need to have a lot of conversations. Some of those conversations have already started. The mayor and I have been talking about this for a while. Dr. Speck came and spoke directly with members of the Tourism Advisory Council earlier this week. I also have met with Dina Kreitler from the Chamber of Commerce and with Brad Arnold from the Community Center, and we're talking about the types of events that we can plan here prior to the eclipse and the day of the eclipse, and probably there will be more than one event in addition to all the things that they'll be doing with the children at the schools. So if you'd like to be a part of that effort, don't hesitate to call 883-7097. That's the number at the Welcome Center, and we will sign you up for some committee to do something for the 2017 eclipse. So thanks for being here tonight. And let's thank Angela again for just a wonderful presentation.